This is the NerdQaxe Revision 7 from Solo Satoshi. And today we're going to be doing a technical breakdown to answer any of the questions that you may have. We're going to take a look at what physically changed on the board, compare it directly to some older versions of NerdQaxes, see how far we can push this thing directly out of the box, and then we're going to add some cooling upgrades to see really how far we can push it. Also, stick around to the end because I'll be telling you how to enter our giveaway for a NerdQaxe Revision 7. Today we have the NerdQaxe Rev 7, the rear fan attachment, thermal Grizzly Cryonaut Extreme thermal paste, a Meanwell power supply, and a Thermalright full copper heatsink with a 92mm PWM fan to test the changes to temperature, power draw, and hash rate. The Revision 7 is going to be similar to the past ones in the regard that it's an open source Bitcoin home miner that runs on 4 BM1370 ASIC chips. And the major difference isn't going to be that directly out of the box, it doubles your hash rate. It's still sitting around that 4.8 terahashes per second range. The main difference with the Revision 7 is that it's a power delivery redesign. That means the main improvement is not just the ASIC chips. The main improvement is how power gets delivered to those ASIC chips. And that matters because when you overclock a miner, the chips are only part of the equation. If the ASICs can handle more frequency, but the power delivery can't keep up, the miner becomes unstable. If the power supply can't safely provide enough continuous power, that becomes the bottleneck. If the VRM keeps getting too hot, that's the bottleneck. If the fan is already maxed out and the ASIC temperatures keep rising, that's the bottleneck. So the whole point of this video is to test the Revision 7 as a complete system. Before we start testing, I want to show the Rev 7 next to an older NerdQaxe. I don't have a Rev 6.1 on hand, so I'm using my Rev 5 as the older generation reference, and that distinction matters. The Revision 5 and the Revision 6.1 are not the same board. The Revision 6.1 already made important improvements over the Revision 5. The biggest ones are the XT30 power connector and the fuse-free design. The Revision 5 uses that old barrel jack style power input and had a one-shot mechanical fuse on the board. The older setup was more limited when you started pushing current and overclocking. The Revision 6.1 improved that by moving on to the XT30 connector and removing the onboard fuse. So the Revision 6.1 is closer to the Revision 7 in terms of the power connector and fuse-free layout. But the Revision 7 goes further. The major Revision 7 change is the voltage regulator redesign. On the older board, you can see the earlier power path design. On the Rev 7, you have the XT30 input, which is rated for higher current and is much better suited for this type of miner than the old barrel jack style connector. You'd also notice that this is where the power delivery layout becomes important. The older versions use the previous VRM configuration. Rev 7 uses the newer two-phase VRM layout adapted from the BitAxe GT design. And that's the point of the Revision 7. It's got cleaner power under load, better voltage stability, better thermal behavior, and more overclocking headroom. This board is made to have more room to scale as long as the rest of your setup can support it. That's what we're going to test. This is the Revision 7 exactly how most people are going to start with it. Stock miner, stock power supply, stock heatsink, stock fan, no extra cooling upgrades. Right now at stock settings, I'm seeing around 4.7 to 4.8 terahashes per second. At the wall, the power draw is around 70 to 71 watts. This would make the efficiency around high 14s to 15 joules per terahash in my test, depending on the exact hash rate and wattage at the moment. The ASIC temperature is set to sit around 60 degrees Celsius if it can, and it's staying there, and the VRM temperature is sitting in the high 50s. With all this, the fan is running around the middle of its range, 55%. These numbers are going to move around a little bit, and that is completely normal. I did let it stabilize a bit before turning on the camera, but hash rate fluctuates, power draw fluctuates, and even temperature fluctuates depending on different reasons. So think of this less as a perfect laboratory number and think of this more as a real world snapshot. And as a home miner, this is exactly what you want to see. It's quiet, it's efficient, it doesn't pull a crazy amount of power, and it gives you 4.8 terahashes per second baseline without needing to modify anything. But that's just the Rev 7 at stock. So now the question becomes, how far can we push it before the power supply becomes the limiting factor? This is really important because a lot of people see a wattage number on a PSU and assume that they can run up to that number continuously, but that's not how I would treat it. The included power supply is rated around 124 watts, but for continuous use, especially if you're running the miner 24/7, you want to think about the 80% rule. 80% of 124 watts is around 99.2. So even though the power supply says 124 watts, I would think of 99 as a practical continuous comfort zone. That doesn't mean the power supply is going to immediately explode if you pass 100 watts. That just means that if you're going to run something all day, every day, you don't want to run the power supply directly at its edge. You're going to want some headroom that keeps the setup safer, cooler, and more reliable. So now we're going to test where that limit really starts to occur. So since we already tested the default settings, we're going to move the frequency to 700 and the core voltage to 1180. After letting it stabilize a bit, the miner is still in a reasonable zone. The hash rate is around 5.5 currently, with the power usage around 82.5. That puts my efficiency right around 15 joules per terahash. On top of this, the ASIC temperature is sitting at 60 Celsius with the VRM temperature at 58 Celsius. Since that looked great, we're going to move the frequency to 750 and the core voltage to 1200. Again, after letting it sit for a little, the miner's doing well. It's giving about 5.8 terahashes and taking 89.5 watts. This puts the efficiency around 15.2. And again, the ASIC temperature is right around 60 degrees Celsius and the VRM temperature is at 59 Celsius. But since all of that looked good, again, we're going to move it up, this time to a frequency of 800 and a voltage of 1240. So after letting this one sit a little bit, this is where I'm going to run into my first bottleneck because I have hit the 80% rule. The miner is sitting around 6.4 to 6.5 terahashes per second with a power draw of 99.7, which isn't way above that 99.2 number, but it's definitely something to note. And with this stock power supply, I would not push it any higher. But just to continue going through the rest of the stats, I'm sitting around an efficiency of 15.5, an ASIC temperature of 60 degrees Celsius, and a voltage regulator temperature of 60 Celsius. Just because we had to stop there due to the power supply doesn't mean the Rev 7 board can't go higher. One of the most important things to understand when you're overclocking is that there's many things that could limit you. Sometimes it's the ASIC chip, sometimes it's the firmware. This time, it was the power supply. But since we've tested that power supply to its limit, we're going to remove that bottleneck and use the Meanwell LRS-350-12. This is a 12 volt, 29 amp, 348 watt power supply. The Meanwell gives the miner plenty of available current, so now the power supply is no longer the thing holding us back. This will let us test the Rev 7 board, the VRM, and the cooling setup at higher frequencies. But with all that said, let's plug it in and put it to the test. The next settings I'm going to do are set the frequency to 950 and the core voltage to 1300 millivolts. After letting it stabilize, I'm seeing around 7.6 to 7.7 terahashes per second with a power draw around 130 watts. This puts the efficiency around 17 joules per terahash. The fan is at 100% here for the first time, which is letting the ASIC temperature slip to around 67 degrees Celsius. Finally, the VRM temperature is sitting around 71 degrees Celsius. This is a big jump from stock. We went from 4.8 terahashes to the mid 7 terahash range, and the only thing that we've added was the Meanwell power supply. But the cost is obvious. Power draw is much higher, the efficiency is worse, temperatures are higher, and the fan is maxed out. You're getting more hash rate, but you're asking more of the entire system itself. That's the trade-off. But now that we've done that, I'm going to test it absolutely maxed out to the top of the firmware range. For this test, the frequency is set to 1000, and the core voltage is going to be set to 1330 millivolts. With the stock cooler setup, the miner is now reaching about 8 to 8.2 terahashes per second, with a power draw around 144 watts. This is putting the efficiency around 17.9 joules per terahash. The fan was already maxed out last time, so it's going to be maxed out again now. So of course the ASIC temperature is going to start rising a bit higher. It's going to be sitting in the low 70 degrees Celsius. Finally, the VRM temperature is sitting around 77 degrees Celsius. This is the practical issue with a frequency of 1000 at the stock cooling setup. Yeah, it can get there. Yeah, the VRM does give it the headroom to do so, but the cooling system is working extremely hard. If your room gets warmer, if dust builds up, if your miner's sitting in a poor location, the temperatures can rise even further because your fan is already maxed out. So as you can see, a frequency of 1000 is possible at stock with the added PSU, but there's not much headroom for temperatures to rise at all. So now that we've maxed it out completely stock and with the Meanwell PSU, let's add some cooling upgrades to see what changes they make. This is the rear fan attachment, and I want to be clear about what it does and what it does not do. The rear fan attachment is not a magic hash rate upgrade. You probably shouldn't expect to bolt this on at stock settings and suddenly see a massive hash rate increase. The frequency is what controls that. The main point of it is airflow. The rear fan moves air across the backside of the board, and that matters because the VRM and the backside of the PCB still generate heat. At stock settings, the rear fan is still nice to have, but it really starts to matter whenever you start overclocking. So first, let's test this out completely stock and at default settings with the rear fan attached to see what changes it actually made. The default settings are a frequency of 600 and a core voltage of 1150. So we'll move it back to that and let the miner stabilize a bit. Once the miner stabilized, the hash rate is still sitting around 4.7 to 4.8 terahashes per second, with the power draw still around 70 watts. This makes the efficiency sit around 14.7 joules per terahash, and the ASIC temperature is still sitting around 60 degrees because that's what it's set to, but the fan is only working 35%. Finally, the VRM temperature is sitting around 53 degrees Celsius. So comparing the performance to the numbers that we had when the miner was running on default settings without the rear fan attachment, you can see that there were some slight changes. The major ones were that the VRM temperature is running about 4 degrees cooler at the time of the snapshot, and the fan was working about 20% less to keep the ASIC at 60 degrees Celsius. So like I said, at the default settings, the rear fan attachment is not mandatory whatsoever, but it's definitely nice and gave us a little more headroom. But now that we've tested it at default settings, let's add the Meanwell power supply back and see if it makes a meaningful change at the max overclock settings. So again, the only changes that we have now are the Meanwell power supply and the rear fan, and everything else on the miner is exactly stock how it comes. We're testing it on a frequency of 1000 and a core voltage of 1330. After letting it stabilize, I'm seeing around 8 to 8.2 terahashes per second again. Like I said, the rear fan isn't what's going to change the hash rate. The power draw is sitting around 142.5, which makes the efficiency around 17.5. Finally, the ASIC temperature is sitting between 65 and 66 Celsius, and the VRM temperature is at 66 Celsius. As you will notice, both the fans are still running at 100% though. So comparing the overclocked results with the rear fan to the results we had without it, these are the findings. We did have a better power usage and efficiency, but I personally think these could be due to how the miner was acting at the time of the snapshot. Again, a lot of these numbers can naturally fluctuate, but what I want to focus on is that the VRM temperature was 10 degrees Celsius cooler and the ASIC temperature was 5.1 Celsius cooler. These are the main things that adding more airflow with the rear fan will help you with. So just as a recap before you make the next cooling upgrade, we've tested the miner completely stock how it comes out of the box until we ran into the first bottleneck with the stock PSU. We overclocked it to its max with the Meanwell PSU, and we've tested the changes that the rear fan makes at default settings and the maximum overclock settings. The only thing we have now to add is the full copper heatsink, and I'm going to apply that with the upgraded thermal paste Thermal Grizzly Cryo Extreme. The heatsink that we're going to use is the Thermalright AXP90 X47 full copper heatsink. Compared to the stock heatsink, this has more thermal mass, it's full copper, and it uses a larger 92mm PWM fan. This upgrade is mostly about the ASIC temperature. When you overclock, the ASICs generate more heat. If you can pull that heat away from the chips more efficiently, the miner can run the same hash rate at lower temperatures. So to be 100% clear, for this test, I'm using the Meanwell power supply, the rear fan, the full copper heatsink, and the Thermal Grizzly Cryonaut Extreme thermal paste. So just like the last times, we're setting the frequency to 1000 and the core voltage to 1330. After letting it stabilize, I'm seeing around 8 to 8.2 terahashes per second, just like the other times, and power draw is around 142 watts, which makes the efficiency around 17.4. Even though the fan is still having to work at 100%, the temperature is much lower, sitting between 62 and 63 degrees Celsius. Finally, the VRM temperature is 74 degrees Celsius. So overall, the changes were a continued improvement in power usage and efficiency, but again, these can be due to normal fluctuations and the time I took the snapshot, but it's a trend to notice nonetheless. One interesting thing to me is that the VRM temperature went up compared to the rear fan test, but as I explained earlier, this can be affected by things such as room temperature, airflow, etc. that could be going on. The main thing is that I'm still seeing it at cooler temperatures than I saw it without the rear fan. Finally, just like what we expected, the ASIC temperature continued to drop with the upgraded copper heatsink and fan. At high overclocks, the lower temperature is the upgrade because it gives the miner more operating margin. When the copper heatsink lowers the ASIC temperature, the setup feels more appropriate for sustained, high-frequency operation. That's the difference between it can hit 8 terahashes, and this is the setup that I would want if I was going to run it at 8 terahashes. But now that we've tested everything, let's do a recap of each component. The Rev 7 runs really quiet compared to any of my other miners that I have at stock settings. Even when you add the rear fan at stock, it doesn't make it loud. Obviously, the higher you overclock it, the louder the fans get because the harder it works, but it's not overbearing if it's something that you're not sensitive to. I would compare it just to a slight white noise in the background, if anything. As for performance, like I said, the rear fan is absolutely not necessary, but the higher that you do overclock it, the more that it helps and the more thermal headroom it will give you. Next, the first bottleneck that we ran into was with the stock power supply. We still got it running at a frequency of 800, which is still great, but if you're going to want to get the most out of the Rev 7, you're going to want to upgrade to the Meanwell power supply. If I'm being completely honest though, the Meanwell power supply is louder than the miner itself. I'm not very sensitive to this sort of stuff, so I have it running in my room along with 9 other miners, but if you're someone that does not like the noise at all, you probably want to think about where you place this miner. Finally, we have the Thermalright copper heatsink applied with the Thermal Grizzly Cryonaut Extreme thermal paste. If you're wanting the coolest and most efficient setup that you could possibly have, this is one of the first things that I would add on. Obviously, without any of the cooling upgrades that we added, we had the ASIC temperature slipping up into the 70 Celsius range, and that's not something that I would be comfortable with running long term. When we added the copper heatsink, it made the ASIC run at about 62 degrees Celsius at a frequency of 1000. This is much more comfortable and it gives your miner more room to fluctuate like it naturally does. So here's my final recommendation. If you're buying your first NerdQaxe, I would go with the Revision 7. At stock settings, it's simple, effective, and easy to run at home. If you want a little more thermal headroom, add the rear fan. That's the easiest cooling upgrade, and it makes sense if your room is warm, airflow is limited, or if you want to start experimenting with mild overclocks. If you want to overclock past the practical limit of the included PSU, upgrade the power supply. Do not ask the included PSU to do a job that it was not meant to continuously do. And if you want to push towards the full 1000 MHz range for long continuous periods of time, I'd want the upgraded PSU, copper heatsink, rear fan, and upgraded thermal paste. That's a reasonable high overclock setup. But the big lesson with the Revision 7 is this. The board has more headroom to go higher now, but the headroom only makes sense if the rest of the system can support it. Do not overclock blindly. Move one step at a time, watch the power from the wall, watch the ASIC temperatures, watch the VR temperatures, and watch the fan speed. And now the moment I'm sure a lot of you all have been waiting for. All of you all who like and comment on this video and subscribe to the channel will be entered to win your very own NerdQaxe Revision 7. And as always, if you want to pick up your own Revision 7 or any of the upgrades shown in this video, check out Satoshi. All the links will be in the description. Thanks for watching and good luck in the giveaway.